All right, so this session of the Coach Professional Development for FTC is featuring a Team 10435 Circuit Breakers. They are going to be talking about their technical expertise and what they did to build their robot and design their robot. So without further ado, I'm going to go ahead and turn it over to the Circuit Breakers. Welcome, Circuit Breakers.
Thank you.
All right, take it away, whoever is ready.
Is my mic working? Let's see.
Yeah.
Yep, it works.
Okay, I wasn't sure because is it supposed to be green? I don't know. But so, hello. We are the 10435 Circuit Breakers. We are from Waukee, Iowa. Our team is made up of 13 members. We are all ranging from 8th to 12th grade. And today we will be talking to you about the engineering process. So the engineering process is pretty simple. Okay, right. Okay, so yeah, I'm Kyler. I'm a sophomore, second year in FTC, and I'm a builder.
Hi, my name is Ari Karnik. I'm a senior. This will be my fifth year in FTC. And on the team, I'm a builder and also a designer, along with being the finance lead.
I'm Sean Eastman. I'm a senior at Northwest High School. It's my fifth year in FTC, and I'm a builder on our team.
I'm Ben Aviles. I'm also a senior at Northwest High School. This is my fifth year in FTC, and I'm also a builder and designer.
Okay, so yeah, so today we're going to be talking about the design process. So let's see. I think you went a little too far, I think. Maybe. I don't know. Are we going in another direction? Okay, yeah, there we go. Now we're on the correct side. Okay, so yeah. So first I'm going to talk to you about how the world uses the design process, and then I'm going to talk about the FTC version. So first is define, as you see. Defining is figure out what you want to do with your project, and then what's the goal, what you want to do with that project. And then second is collect. You want to collect your information. You want to research what you need to do in order to accomplish what you need to do. And then third is brainstorm and analyze. To brainstorm and analyze, you need to come up with ideas for what your projects want to accomplish. Fourth is develop. After you've come up with an idea, you want to make a prototype. So you want to make a prototype because this way you can see what's good about your robot, what parts you need, and what you need to fix about it. And then fifth is feedback. You get ideas from people, and then they tell you what is good about your robot, what's bad about it, and you take that and you just make it better in a way. Sixth is improving. Take all that feedback. Yeah, I kind of already said this, but whatever. But you just take the feedback you've gotten and then you implement it into your robot. So next is the FTC way. So first is to evaluate the game. You want to study the game for the season. You want to learn everything you can. You want to learn the rules. You want to learn the setup of the stage, all of that. And then you want to come up with ideas for your robot on how you want your robot how to accomplish all the tasks at hand. And then second is brainstorm. You want to come up with the ideas as a whole team, not just individuals, but the whole, on how to use parts and how to build a functioning robot that can do the required tasks. Like last year, where we wanted to shoot rings into the tower thingy. I don't remember what it's called, and then you want to shoot all the PVC down. But you also want to do that fast, efficiently, and you want to do it at a low cost. That is very, very important. And then third is to develop a plan. You want to figure out how to attack the tasks. So like to make it easier or to just, I don't know, but yeah. And then you want to figure out what you want your robot to do, like the autonomous mode, or you just want to figure out the basic plan on what you want to do. Fourth is prototyping. You want to build your robot of old parts or household items that you can find, so you can see what it looks like and how it could function. And then, yeah, and then fifth is to improve. So you want to find out ways you can improve on that prototype, and then just move on from there and advance forward. Sixth is to put it all together. So take all that you've learned into one final product. And then you can also take all the things you've learned in like past seasons and then implement it into the current season. So that way you have a basic knowledge of that. So next is evaluating the game. Next slide. So breaking down the game. You want to understand how the game works, how the points are scored, how many points you can get per block or per ring, etc. You want to be prepared for anything that comes in your way. You want to consider all options as it said on the slide. You want to set goals that your team can accomplish. Don't set goals that could be impossible or are just really, really hard to do. So next slide. Next is understanding the field elements or brainstorming. But a lot of games in the past years have known that have been used in the current game of the season, and this can be used as advantages to veteran teams because they'll already have an experience in the past years of like all the seasons. So like last year, they always have the field, and they already had parts, or they already had knowledge of what they need to do. They already had driving skills, so that would put an advantage to them. And then it's also gonna give you a chance to bring back ideas that you have used before, or that you've come up with before that you haven't used. And yeah.
All right, thank you, Kyler. Next, we're going to be talking about brainstorming and developing a plan. Oh, there we go. Collaborative thinking. So, a big part of robotics is collaboration, and especially during the early stages of the design process. And so, as a team, you'll need to get together and brainstorm different ideas based upon what you know so far, whether that be the reveal trail or maybe a similar game happened in a previous season. So, in the picture on the right, we're all gathered around a whiteboard and pitching our ideas to each other. So, this not only helps get ideas moving, but also ensures that everybody on the team can get involved in some way. It's okay to talk about theoretics at this point. Like I said, maybe only the game trailer has been revealed and you only can see what's going to happen. Even if you don't have any field elements or anything physical to work with, the reveal trailer can give you a good sense of what you'll be seeing and doing throughout the season. Here it is. It doesn't have to be boring. So, like I said, brainstorming is a collaborative process. And the context of this picture is, I remember one time at a meeting, we were talking about our intake, because this was last year where we were intaking rings. So, at some point, somebody brought up Hungry Hungry Hippos and how the hippo kind of jumps out at the balls in the pit. So then they got us talking about, okay, how does that intake work? Lo and behold, we put out a Hungry Hungry Hippos board game and began playing. Turns out it's actually friction that makes the hippo's mouth jump, so it wasn't very helpful for our information throughout the season, but it was a cool bit of knowledge that we could have only gotten through brainstorming. Alright, sketches and drawings. Sketches and drawings play a crucial role in the development of your robot. Drawing out your ideas allows you to paint a precise picture of what you want from your robot. And in addition, this will also help other people understand your thought process and how to contribute to your blueprint or theirs. Now, our team usually doesn't use CAD this early in the design process, and you're probably wondering why, because CAD is a very useful tool throughout the entirety of the season. So the reason is that, like I said, in this early stage of your design process, you're probably going to go through a lot of changes, both in your design and your physical robot. Really, we find that it end up being a big hassle to continue remodeling all those little changes that really could all just be done at the end when you think you have a finished product of your robot. And like I said, once you know what the final product of your robot is going to look like, then I would take time to CAD out your robot because it's helpful to look back on for the notebook, and judges love it. So, one of the big parts of robotics that took us a while to understand is you want to build components from the start, not a robot. And when I say that, I mean you want to design your components before you put together your final robot, because if you don't know if your components work, how will you know your robot's going to work? And I'm not going to talk too much about this because Arya and Sean will be talking about it later, but just be sure when you're making your sketches and designs to explain your thought process along the way. Research. Research is probably one of the most underused tools at your disposal. I think I said it before, but many games in FTC reuse elements or ideas from previous years. This essentially gives you a gold mine of information to sort through before the season even begins. Actually, the top picture is from I think it's 2013 FRC game Ultimate Ascent. I think I forgot which team it was. But anyhow, the bottom picture is from last year's Ultimate Goal. Now, pretty much the goal of Ultimate Ascent was the FRC game above, was to intake frisbees and shoot them into a goal. And if you played last year's games, that sounds kind of familiar, doesn't it? And on that topic of research, at any point in the season, it's always a good idea to see what other teams are up to on social media. If you're stuck, this can point you in the right direction to see what needs to be fixed and to draw inspiration from their ideas. Developing a plan, which is what you'll do after you're done brainstorming. Now that you have a list of ideas that you want to test, it's time to figure out which ideas should be given priority over others. You don't want to immediately jump to the high risk, high reward option. Instead, you want to focus on basic and simplistic designs. 10 points is worth more than 0. Once you have a basic component that can run efficiently and effectively without error, it's time to begin working on either building off that or designing more complex designs. And setting deadlines for when prototypes should be done is a big part of robotics. You got to make sure you're on time with yourself and the goals that robotics gives you. And here's a video of... So when I was talking before about testing components, part of the deadline process is setting a deadline for when those components need to be done to ensure that the final robot will be ready when you say it's due. This is just a little video of us specifically testing our intake, making sure that that works before we move on to the next slide and see what we have. And at this point, after we figured out that, alright, our shooter works, the next part of the plan was, I mixed that up. After we figured out that the intake works, the next part was testing if the shooter worked. Like I said, deadlines, that's big takeaway here. And after we knew that our shooter worked, it was time to put the two together and find a way to bridge them. And this was where that little, I guess that's kind of hard to point out, but the little back black flap at the bottom, yeah, there we go. So that was a little chute that bridged our intake to our shooter. And we could have only found out that we needed that after testing first the intake, then the shooter, then working those two together to figure out, alright, how do we bridge those two? And that leads us to our rough robot. And I believe our deadline was set. We wanted to have like a rough robot that could drive, intake, and shoot by about mid-November. And we accomplished that goal by setting deadlines, as a vocab word here, and also making sure we tested each component along the way to assemble our final product, or semi-final product. Going into greater detail means making the most out of your prototyping. Before you begin building, you want to make a clear outline of what it is you're trying to test and what you hope to learn from it. And when we're talking about prototyping when we were prototyping different intakes last year, we were trying to figure out which material would work best. This is something very crucial to a robot going forward and just a good piece of, information that we needed. The top picture is of us using surgical tubing to try and bring the ring onto the, I think it's a piece of like Lexan or something. And the bottom picture is us trying to use compliant wheels to kick the ring up onto the piece of Lexan. Now, like I said, what we were trying to figure out here was which material would work better. And through this testing, we found that, alright, surgical tubing works better. However, we also learned in the process that those green compliant wheels acted almost as like a kicker for the ring. If the ring ran into it on the ground, it would kick the ring up, something that would be very important to us later in our final version of our intake. There's no doubt that you'll encounter some kind of constraints along the way, but it's a matter of how you overcome those challenges that determine the success of your team. Some of the most common types of constraints include stuff like time, creativity, and lack of materials. And this is when you must work with a team to allocate different tasks to different members. And of course, this is a pretty difficult thing if you're working with a small group of people. But if there's enough where you can delegate different tasks to different people, it'll help get things moving much more efficiently. For example, so if the build team needs more materials to work with, that means they need more money, which means the finance team needs to do more fundraising to bring that money. If there's lack of creativity, that means it's time for the build team to go and look for outside inspiration or talk to any kind of help to get things moving. Robotics is a team effort, and usually not one person can plan, prototype, build, fundraise, and do everything alone.
Thank you, Ben. So I'm Sean, and I'll be talking about prototyping and documentation. So I think that is one slide too far. Yep. So what prototyping is super important to the design process. So what prototyping is at its core is just testing concept. So no matter what idea you have, just build it. What you're building is just like a rough build to test if the idea is sound or not. It doesn't have to be a final product. Just use what you have to build your prototype. You don't want to order anything because you don't want to waste your money on something that you don't even know if it's going to work or not. So use what you have, see if the idea will work, and then if it does, that's when you can put your money into it later. So for example, in the bottom picture, that is a prototype shooter that we made last year. We made it out of wheels that we already had and a scrap piece of Lexan that we had cut from previous year. So we threw this together and then we tested it. So if your prototype works, that's when you can then invest more money and time into it. So from here, once we figured out this worked, we custom cut a piece of Lexan and we ordered a wheel that would be a more effective shooter. And the reason why we did this is, once again, because we tested our idea with parts that we already had and we figured out that it worked. Another thing that I cannot stress enough is to keep your ideas and your prototypes simple. So a lot of times mechanisms can get very complex, right? And so for example, in one of my first years as FTC, I went to a competition and I saw a team whose robot it set its feet out on the ground and it steadied itself. And from there, it expanded into a giant arm that would reach all around the field. In my first year, I thought, that's such a cool robot idea, right? And it would be amazing to have a robot like that. But the thing is, with something like that, if one thing fails, the whole robot is out of commission, right? If one motor fails, if one servo fails, then you can't score any more points after that. And that's why it's important to keep it simple and have as little failure points as possible. So what a failure point is, right, is if something were to go wrong, like it's anywhere where something that could go wrong. And as little, it's obviously good to have the less that can go wrong, the better. And that's why it's important to keep it simple. Yeah. So another thing I want to emphasize is building and testing quickly, because especially at the start of the season, you're going to have a whole bunch of ideas that you've brainstormed with your team, and you're going to want to figure out which ones work. And if you spend too much time on this, you'll never get to building your actual robot or deciding on where to continue from there. But while it is important to like test quickly, you also want to give each idea an adequate amount of time. So you don't want to rush too fast through something, and you could have an amazing idea, but it because you rushed through it, it didn't turn out well. So for example, in the top picture, that's us testing a prototype shooter that we made. So when I say test quickly, I mean that you don't have to have it, as a final product made, right? We basically just have a metal sheet with a wheel and a motor, and then we literally propped it up on a piece of foam just to see if it would actually shoot. So we plugged the motor into a battery, we had it spinning, and then we hand fed it rings just to see if it would work. So yeah. So after you prototype, what you want to do is you want to analyze your results. So the things you want to be asking yourself is, did the prototype work as intended? And then also on top of that, you want to see if it's realistic. So is it small enough that could fit in your robot? If you put it on your robot, will it interfere with any mechanisms that you already have? Will it turn out to be too clunky to be actually usable? And you want to pay attention to game rules, because maybe when you had the idea for it, you didn't know about a game rule that it could break, and that could bring problems to your team, like penalties. Then next is risk versus reward. You want to decide if it's beneficial to continue with the idea. And some things you want to be thinking about is if you have other ideas that are better, and also if you want to generally go with the more consistent idea. As I said before, it is very important to have simple components, so you have little failure points and you can have a robot that is as consistent as possible. So next is documentation. So documentation is something that you will use throughout the entire design process. So for example, when you evaluate your game and you make your plan for how you want to score, and what challenges you want to do, you write that all down, put it in your engineering notebook. When you're brainstorming, you're going to be writing out your ideas, explaining them, you're going to be sketching them, drawing them. All of that is great to have. When you develop a plan, write out your plan, write out what ideas you think will be good and where you're going to go with them. And every single prototype that you make, write about it. Write what you learned from it, from building it, and also what you learned from testing it. Because later on in the season, it's going to be hard to remember those kind of things, and it's very nice to have them down on writing. So describe everything that you've done in detail. So every idea you have, describe it in detail. Every prototype you make, describe that in detail. Every change to the robot you make, have it all down, so it's logged, right? and you want to keep your information clear and concise. So it's very important to have pictures and videos, right? So every change you make, especially to the robot, take a picture of that. So pictures are very useful, right? So whether it's through presentations like this, or just to help you remember the season as as it goes on, or to put pictures in your notebook. Pictures will be used for everything. So it is very important to have them. So you're gonna want to store the pictures somewhere online so that every member of your team can access them. It's also very important to have an organization system for them. So for example, our team uses Google Drive. So every picture we take, we have it organized into folders by date of when the picture was taken. And then we name them, something to do with what the pictures were about. And so, sorry, can you back to the slide? So for example, last year, we had close to like 60 folders of pictures and close to 1,000 pictures in total. And so as you can see, pictures are very important. But while you might not use all of those pictures, they're all, you never know what you'll need, what like picture or video you need. So you should take pictures of everything, and you won't use it all, but it'll be good to have. Okay, so lastly, you're gonna basically, why you're documenting everything is so you can put it in your engineering notebook. So everything that you've wrote down in the past, everything that you recorded, you're gonna go through it and you're gonna revise and edit it, right? Because while it's good to have all that information down, you probably won't be putting all of that into your engineering notebook for the judges to read. Then you also need to organize your engineering notebook, and a great way to do that is to use a template. So not only do templates keep your notebook organized, but it also makes it look very good. So a good thing to do is to sort all your information in your engineering notebook into headers. So headers stand out and they make it easier for you and the judges to easily find what you're looking for. So then also pictures. Pictures are very important for the engineering notebook, and this is another reason why you need to have a good labeling system. So when you're writing in your engineering notebook and you want to find pictures for it, you can go through your organization system and you can find the pictures that you need to put in your engineering notebook. So pictures not only make your notebook visually appealing, but it also just it lets the judges see what you're talking about when you do your documentation. And then next, Arya will be talking about seeking improvement.
Thank you, Sean. And sorry to Sean, Ben, and Kyla, and also sorry to you guys about Zoom. It's not really working with me today. I don't know, like jumping slides and stuff. I apologize, but I'll be talking about seeking improvement. I'll try to seek improvement on my Zoom skills. But relating to the robot design process, the first thing you need to do is reflect upon your prototypes. So you first need to think about what went well and what went wrong, which this was touched upon earlier in our presentation, but your issues can really stem from many different things, but that kind of narrowed it down to 4. It can be through programming, and that is when your build team creates a prototype that they're very excited about, but you need to make sure that you're working with your programming team to make sure that you can actually design the code to implement that prototype. As Ben was talking about earlier, robotics is a team effort, and you really need to be hand in hand with your build team and programming team while prototyping, because sometimes your ideas might not be able to be executed by a programming team, and also vice versa. Along with that, sometimes your idea is just not suitable for that game, or for whatever reason. Sometimes you think it's a really good idea, but it's just, not all ideas will work, and that's something that you really need to keep in mind. Failure is an important step, in your journey to success in life, but also in prototyping. Furthermore, another issue can stem from your execution. Sometimes you have a great idea, but you might not be able to execute it. And that's something you also have to keep in mind. Execution of ideas is really important. And sometimes that's why this year, or I guess last season, we had multiple different variations of our shooter design. We tried, 2 wheels, 3 wheels, 1 wheel. We had many different trials, and we went back to them many times because we wanted to make sure that we gave each idea a fair execution in the prototyping, because you have to make sure that when you actually test, it's like scientific. And while you do have to test quickly, you should try to give each idea, as Sean said, enough time to actually make sure if it works or doesn't work. Furthermore, your last issue can be practice. And this is not practicing like making prototypes, it's actually practicing in relation to the robot. You build a component, but do you give your drive team enough time to test it? Do you give enough time for your programming team to, flush out the idea? And sometimes it's just not possible. And that's another issue where that's another area where issue can rise from. Another step you need to take is, after realizing those, is you need to implement feedback. And that's something that also goes hand in hand with the connect portion of FTC. Connect outreaches are a great way for you to learn about how to improve your robot and really take advantage of mentors and their expertise. These people, they want to help you, so take advantage of them. And it's really great when you can find a good mentor who's really interested. And over the past years, we've had many great mentors, and we're very thankful for the opportunity to come talk to them. For example, in this picture in the top right here, that's actually Ben talking with 2 of our mentors. I think at this point about linear slides probably, as we were really struggling with linear slides that year. And yeah, we were very grateful for them. We've learned a lot from them. There's a lot of like industrial tools and techniques and items that we've used through that. And there's countless examples of times that they've really been helpful for us. So take advantage of mentors and expertise, work with your outreach team, your connect team, and get involved with connecting to these outreaches. And these can, be John Deere. John Deere is a big supporter of FTC, local engineering companies, manufacturing companies, any of those type of STEM related things. You could probably find a mentor there. Furthermore, you need to talk to other teams. And obviously with remote events last year, it wasn't able to be as beneficial for teams, I would say. But obviously there's still social media, but there's really a great sense of camaraderie at competitions. And that's like a really good thing about gracious professionalism. Competitions are a great resource for teams to learn how to improve their robot, how to look at other designs, and that's not necessarily copy them, but learn from them, learn from, what they're doing well, but what they're also not doing well. So you can see how to implement those learning into that knowledge into your prototyping designs. And also you can ask other teams for help. Many teams will be very willing to give their advice or their opinion on issues if you have help, especially with rookie teams. I really recommend rookie teams talk to other teams, because most like senior teams love to give advice to younger teams. So just really don't be scared, reach out. The worst they can say is no, or they won't give advice. But that's very rare. Countless times we talk to teams, both for help and giving help. It's just a great experience. Take advantage of it. Finally, discuss with the drive team as well, because at the end of the day, they're the ones that are going to be driving the robot during the game. So you need to understand that your prototype might not work well in in-game situations. It might work well on a practice field with just one robot. You have to consider, we'll work with 3 other robots on the field sharing that same space. Furthermore, with where drivers stand in relation to the robot on the field, you need to make sure, like, can they actually see whatever that prototype is doing? And if it's blocking their view, for example, then even though the prototype might work, it's taking away an advantage that they need. So that's something to really consider as well. After implementing and taking feedback, you need to plan redesigns. So firstly, you need to combine your own personal team reflections along with feedback to look at redesigns. And you should take into account all feedback to make decisions. And this does not just have to be from your build team or your drive team. Take feedback, from someone who might not generally work on the robot. Because a lot of the times the build team members, they get very focused on the robot and they're only seeing one way, one perspective on an issue. If you ask someone who's not really working around the robot that much, they might have a completely out of the box thinking on that issue, and that could be your solution right there. Furthermore, be rational about redesigns. Don't be too crazy with your redesigns, because sometimes you need to consider time. Time is worth everything, and you can run out of time very easily. Competitions can sneak up on you, and you need to make sure to stay ahead of those. Finally, check resources. As Ben said earlier, money is usually a big issue for a lot of these things. And even though you can be resourceful, like Sean said, sometimes you don't have those scrap parts that you need, or you might not have those wheels already in your kit. And as you grow as a team and get more experience, you will start to have those spare parts that you can use from past years to make more prototyping. That just comes with more resources. But just make sure that the redesigns you do don't take away resources that you might necessarily need for competition day. And going on competition day, I need to stress this enough. Think about your competition deadlines, because you might sacrifice performance at one meet for the future. For example, last year we were thinking about redesigning a robot and like complete a full new redesign, as we kind of felt that we hit the max on our current chassis. So we decided to redesign a robot like 2 weeks before super qualifiers, in the hopes that we could still use our current robot at super qualifiers to get us to state, but then our redesigned robot would be able to perform at state at a much higher level. And we had like a week-long discussion about whether we should do it or not do it, because we needed to decide the long-term effects versus the short-term effects. Did we have enough time to do the redesign? Did we have enough resources? Did we have enough build team members who could meet? Because we had a lot of seniors last year, so they were busy with college applications. Our juniors were busy with school, junior school year, tough year. We had a lot of different activities going on for everyone, and we needed to make sure that we could do it. And then we decided to do it because, like I said, we thought about the long term versus the short term, and we decided it would make more sense to invest time for the long term versus the short term, as we already felt we maximized the performance out of that chassis. And it paid off well for us, but it's something that you really need to consider. Competition deadlines, very, very important. Can't stress that enough. Finally, the last step, you need to put it all together. So firstly, assembling your components and testing together. And that testing together, while it's a short part on top of this title, very important. You need to figure out how everything works together. Because like Ben said, what we learned is it's about building components, but you need to add all of these components together on the same chassis. And you need to realize that not everything will work together. For example, you might have an intake, but is it too tall so you can't shoot? And you might not have thought of that before. So when you are designing components, think of it individually, but also think of it in the grand scheme of things. Think of it like a puzzle, right? You need to make sure all the pieces fit together. And you can like brute force a piece in, but it's not going to solve the puzzle, right? Like it's just like a short-term fix. The puzzle won't look good. It might not finish. You need to make sure that it all fits together. And you need to also run matches. And this isn't capitalization. Please, you take one thing away. I want you guys to run practice matches once you add everything together, because you need to practice to see progress. Issues will arise fast from things that you would never expect. You might run on a first competition day, you're like, yes, this idea is going to work. We ran one test match and it worked perfectly. The next thing you know, it all falls apart. And you're like, wow, how could that have happened? If you run test matches, you'll see these issues. You want a consistent robot that works in all test matches. And usually for our team, we try to run around 5 to 6 test matches when we start designing new things, but sometimes we run much more, or many more, I should say. And I cannot stress enough, please run practice matches. It will really save you a lot of time and hassle, a lot of pain when you get on the competition field and you realize that it doesn't work. And this is why deadlines are super important. Build these times in. You ideally want to have a week before competition day where you are practicing. And obviously you can still make small changes, but that week should be dedicated to letting your drivers practice, practice, practice. And finally, implement what you've learned overall. So now this is where you look at previous designs to see issues. And this is a really important step. It's like an overall reflection on your whole process. So you need to look at execution. What could you have improved on? Efficiency, or just general building techniques, stuff like that. Resources. In the past, like I said, I might have mentioned, we didn't have enough money. So in the future, try to raise more money before so you have those resources when you need them. Finally, time, deadlines. Can't stress it enough. Deadlines. And practice, please practice. I beg you guys. It was the biggest thing for us is practice. And I think we're running out of time now, which is perfect because I see they turn the cameras on. So thank you guys.
Oh,
We'll take
no, you're
questions
fine.
now, so.
We do have a few questions, if that's okay. We just have a few more minutes left. What sort of labeling system do you use for your photos?
I can talk about that one. So we store all of our photos in Google Drive. And so at every meeting or at an outreach, when we take pictures, we create a new folder for that meeting or outreach. We label that based on the date of the meeting or outreach. And then we also put some kind of like heading about what it was about. So let's say, this meeting, we're working on our intake. So we would label it like whatever date it was and then out intake. And that's how we would know when we did it and also what the pictures were about, so we can go back and find those pictures later.
How did you do all of this? And I don't know what this was referring to while working remotely. Did you get together at all last year, possibly this season, or do you do everything via video conference?
Come on, Becca.
I know.
I can take this one. So at the start of the year, what we did was we tried to do outside meetings, like during like September when the game came out, to like social distancing and we wore masks and everything. And then during the season, what we did for build meetings is we did a sign up sheet where we limited to like 3 or 4 members for multiple reasons. A, small meetings are usually more productive for us because we can only have so many hands on the robot. But B, COVID, you don't want too many people in a room. And then we do one big team meeting per week, and we did that on Discord. So that was like virtual. And then this year, we're not really sure yet how we're going to do meetings. So far, we've done a mix of in-person and online, but it's kind of like, situations changing every day. So we'll kind of see closer to the kickoff on how things roll.
Very cool. Awesome. Any last or final comments? Circuit
Well, just-
breakers, I look forward to seeing you at the state fair.
A follow-up on that last question. The team, all members of the team had to buy into the sharing of the resources and who owns it or who is in charge of all of the resources, or how would that work?
Are you asking about like who owns the parts?
Yeah, well, your common repository for all your documentation, your pictures, all that fun stuff.
Yeah, so we actually made, for our pictures and stuff, we made a Google Suite thing because we're part of the Pathfinder Box nonprofit. So we made like a nonprofit suite. So everyone just has their own like not pathfinderbox.org email. And then for team parts, it's kind of like, I guess, owned by the nonprofit since we're part of the nonprofit, but like what we plan to do is just pass the parts down as the new kids come up. This year, our team is like 6 seniors and like the rest of them are like 8th and 9th graders as we're going to mentor them. So we're just kind of passing it down.
Yeah, I meant like responsibilities as far as ownership goes.
Okay, sorry, my bad.
That's okay.
I took that question literally. We kind of just like split the roles as like when we started 5 years ago, it was like what everyone was interested in. So I kind of gravitated more towards finance. Ben became more of like the build lead. And actually I think Ben's coming back in now. And what we kind of did was like team interests, personal interests. And then we all just obviously work as a team. We're not confined to our roles. Like I'm the finance lead, but I still build, right? Ben's the build lead, but he still sets up outreaches. Like it's like we all do things together. It's not just one person doing each individual part, if that makes sense.
Cool. Thank you.
Any other final comments or questions? Circuit breakers, you did a great job. Fantastic.
Yes, thank you so
I
much.
would certainly
Thank you.
recommend folks to follow their YouTube channel. I know I have watched several of your videos and have learned quite a bit. So yeah.
Thank you. And yeah, if you guys ever have any questions, feel free to email us or reach out on any of our socials and we'll talk to you guys. So.
Absolutely. I'm going to go ahead and stop the recording.